Hello everyone, welcome to the video solution for Edexcel. This is Edexcel IAL Summer 2014 Unit 2. This is the first video, part 1. So let's start. Question number 1. Two resistors, each of resistance 4 ohm, are connected in parallel. Which of the following is overall resistance of the combination? Remember, this is all about resistance combination, and they are saying you are connecting two resistors in parallel. So if you have a two resistance R1 and R2, and you are connecting these resistances in parallel like that, and this is R2. So the total resistance will be 1 upon R is equal to 1 upon R1 plus 1 upon R2. You add the reciprocals to find the total resistance, and clearly you can see that both have the same resistance. So 1 upon 4 plus 1 upon 4, and if you simplify, the answer will be 2 by 4, and this is not R, remember this is 1 upon R. So 1 upon R is 1 upon 2. That means R is equal to 2. So 2 ohm. So your option is B. Question number 2. A wave is traveling across the surface of a water tank or water. The graph shows how the displacement of water at one position on the surface varies with the time. So this is displacement time graph. Which property of the wave cannot be determined using only the information from this graph? Amplitude. Yes, we can find amplitude because amplitude is the maximum displacement from the mean position. Clearly amplitude is this much. So you can find the height, it will give you amplitude. So we can find amplitude. Frequency, yes, this is a time axis, so we can find time for one wave till here, and then frequency is 1 upon t. So frequency can be found. Time period, of course, this is the time period of one wave. Indeed, we cannot find the wavelength from this information or from this graph. So wavelength cannot be determined using these information. So the option is D. Question number 3. A student measures and records 4 values for the length of a wire. Length, these are some data set given, and which of the following should be recorded as the mean value of the length in centimeter? It is a typical question. Generally they give you some values in a data set, in the form of a data set, different values, more than one values or repeated values, whatever it is, and they ask you to find the mean value. So when you find the mean value, generally we add the given values and divide it by their numbers, but we take care of the anomalous reading. So clearly you can see that this 41.1 is anomalous reading, so we exclude this and we find mean rest of the three quantities. That means 50.2 plus 49.9 plus 49.4 divided by 3, and then it will give you 49.8. so your option is A. Question number 4. During a scan of an unborn baby, a series of ultrasound pulses are transmitted through the mother's body and reflected pulses are detected. The duration of each ultrasound pulse is kept as small as possible. Which of the following is the reason for this? So the large number of pulses can be used. No, the time duration is very short, so we cannot send a large number of pulses, so number of pulses will be less, so that the shorter wavelength of ultrasound can be used. There's nothing to do with the time with the shorter wavelength. To enable the more detail, yes indeed, it's option C, to enable more detail to be seen. Suppose we have some structure and you are sanding, so if you need to see the detailed structure, so you need to send pulses very small interval of time, so you can analyze minor details or more detailed shape of the object, whatever it is. So option is C. Question 5. A narrow beam of electron is passed through a graphite crystal and is then incident on a fluorescent screen. The pattern observed on the screen is shown. This is a typical shape of shape of electron diffraction. Remember, electron diffraction. So which of the following conclusion about the electron can be made from this pattern? The electrons are being attracted to the graphite nuclei. No, the electrons are being scattered. This is not a scattered pattern. The electrons are being diffracted. Yes, so option is C. Question number 5. No, it's a 6. Yes. A lamp with an output of a lamp with an input power. I'm sorry about that. It's not output, it is input. A lamp with an input power of 500 watt illuminates a total surface area of 2 meters square. The lamp has an efficiency of 30%. Which of the following is a radiation flux incident on the surface? So radiation flux is the power upon area. So remember, flux is power upon area. So the power is some energy is falling upon some surface. In this case, efficiency is given and input power is given. So looking at input word and the efficiency, I can say that the efficiency E is output power upon input power. Clearly efficiency is 30%, so I can write this as 0.3 is equal to output power I need to find, so I can divide with the area, output power divided by 500. And if you solve this, so P naught is 0.3 times 500 will give you 150 watt. This is your output power. So the flux is 150 divided by area, and area is 2 meters squared divided by 2. So flux is 75 watt meter minus 2. So option is A. Question number 7. The diagram shows two copper bars M and N with square cross sections as shown. So this is M, cross section is X, and the 2X with these are the square cross sections. Square means the length is X and this is also X. This is 2X, it will be also 2X. Two bars are connected end to end in series in a circuit. The drift velocity of the electron in bar M is V. So which of the following is the drift velocity of electrons in bar N? So if you see, the drift velocity V depends on current, charge density, and A, because they are in series, so current amount of current is same. So clearly drift velocity is depending on the area. And if you see the area of the second bar N is 2x into 2x. That means 4 times of x square. So 4 times of x square. So that means the drift velocity is v by 4. So it will be quarter. So option must be A. Question number 8 and 9 refer to the following experiment. A lamp is connected to a power supply of potential difference V. The lamp is switched on at time t equal to 0. The graph shows how the current through the lamp varies with the time. So this is current and time graph. And okay, so let's see. Question number 8. A data logger is used to measure the current. Which of the following is the reason for using a data logger in this experiment? So using of data logger, it's all about, the reaction time is less or almost no reaction time. There are some other purpose. So it is more precise. It can take reading in a short interval of time. It can take reading over a long length of time. It can plot a graph. No. So out of all these it can take reading in a short interval of time, and clearly you can see you have a time interval is 0 and 0.2 second, 0.4 second, 0.6 second, and no human can take reading in these smaller interval. That's why we are using data logger, so we can collect reading in a very short interval of time. It is not the time interval is not like 2 second or maybe 5 seconds, something like that. It is a decimal time into fraction of the time, second. So option is B. Question number 9 from the same graph. Which of the following is numerically equal to the work done on the lamp in the first 0.16 second? So this is 0, and 0.16 second is in fact, if you see, this much. That means you need to find the work done. If you recall that the definition of voltage or potential difference is work done per unit excuse me, work done per unit charge. So it is Q. That means work done must be equal to V into Q, and Q is I into T. This is the definition of charge, I into T, and clearly I into T is area under graph. So this region is I into T. So W, the work done, should be equal to V into area under graph. That means option is A. Question number 10. The temperature of a negative temperature coefficient thermistor is increased. So the temperature of NTC is increased. Which of the following has the greatest impact on the resistance of the thermistor when its temperature is increased? Its kinetic energy of conduction electron, increase in the lattice vibration, increased number of collision between conduction electrons and the atom, increased number of conduction electron. Yes, if temperature is increased, then resistance is decreased because the number of conduction electrons are increased. That's why we say that the resistance has decreased. So the option is D. Question number 11. A student carried out an investigation using conducting putty. Conducting putty is a material that is a good conductor and can be made into different shapes. The students formed a conducting putty into cylinders of different sizes. Coins were pushed into a conducting putty at either end, and so that the crocodile clip could be attached to the conducting putty into the circuit. Okay, so this is a setup. Fine, the students made a cylinder of a conducting putty of length 0.05 meter and the diameter of 9 millimeter. Calculate the resistance of the cylinder of conducting putty. Resistivity of the conducting putty is this. So we are given resistivity, we have resistivity, we have length, and we have diameter, and we need to find the resistance. Clearly straightforward question. So we know that resistance of a conductor in terms of resistivity, R is equal to rho L by A. You just need to substitute the value. Rho is given, length is given, area. Yes, we don't have area, but we have diameter. So we can figure out area from the diameter. So you can say that you have R is equal to rho, and rho is 4.2 into 10 to the power minus 2. So 4.2 into 10 raised to the power minus 2 into length. Length is 0.075 meter. 0.075 divided by area. Area is pi r square, and r is half of the diameter. R is equal to d by 2. So r square must be equal to d square by 4. So you can say that the pi r square and 9 into 10 raised to the power minus 3, it is because this is in millimeter, so I am converting into meter. 9 into 10 to the power minus 3 divided by 2 whole square. So when you solve this equation, then R would be equal to 49.5 ohm. This is your final result. Part B. Two cylinders of conducting putty are connected in parallel across a battery. The cylinders have the same length but different cross-sectional areas. Explain why the cylinders with a larger cross-sectional area will reach higher temperature than the other cylinder. So you have two conducting putty connected in parallel, and one cylinder has larger cross-sectional area. So you can see that you have a relation resistance is equal to rho L by A, and resistivity and the length for both cylinders are same, so you can say that resistance is inversely proportional to the area. That means if area is larger, then resistance would be less according to the relation. And in parallel circuit, power dissipation is V square upon R. This is for parallel circuit. For parallel circuit. That means if resistance is less, then power dissipation, it's a power dissipation would be large. That's why temperature is increased. So you need to link Larger the area, lower the resistance, and lower the resistance, more power dissipation in parallel circuits. That's why temperature is increased. So you can rephrase this statement. Thank you very much for this video. See you in the next one. Thank you.